Hello students, welcome back to your class. So in today's class we are going to solve some of the problems in exercise 1.3. Okay, see the first question. Suppose that 120 students are studying in 4 sections of 11th standard in a school. Let A denote the set of students and B denote the set of sections. Define a relation from A to B as x related to y if the student x belongs to the section y. In this is this relation a function? What can you say about the inverse function, the inverse relation? Okay, see here what they have given is 120 students are studying in a school. 120 students are studying in a school. Okay, it contains 4 sections. Studying in 11th standard in school, and they are split into 4 sections. So the students are taken in set A and the section is set B. Okay, set A and set B. Here A, B, C, D, that is 4 sections, and here that is written 120. Okay, so is this relation a function means, see here all the students are marked to any one of the section here. So since every students are studying in 11th standard contains 4 sections, any one of the all the students should be in any one of the section. So A to B this relation is a function. But see here reverse, we cannot say that this section must contain this particular person. See here this first person, if he is studying in A section means, see this B. When we are taking in reverse, we cannot say B section contains first student, second student, third student. Therefore, we cannot say in the reverse order. Okay, we cannot say in the reverse order. This is the answer for this question. That is for A to B, it is a functions because every student will be included in any one of the section. Therefore, this A to B is a function. But we cannot say this relation B to A is a function because we don't know. Taking the section, we don't know which student will be there. We cannot say this section contains this particular person. Okay. Then the second sum, what is the value of f? They have given f of x is equal to minus x plus 4 if minus x belongs to minus infinity less than x less than or equal to minus 3. Okay, and then x plus 4 if minus 3 less than x less than minus 2. X square minus x if minus 2 less than or equal to x less than 1. X minus x square if 1 less than or equal to x less than 7, 0 otherwise. We have to find the value of f of minus 4. They are given 5 values, minus 4, 1, minus 2, 7, 0. F of minus 4. Okay, f of minus 4. Minus 4 is in which interval? Minus 4. Here, right? Minus infinity to minus 4. Here it is minus 4. Therefore, this should be used. That is, instead of x, we should put minus 4. Minus of minus 4 plus 4 is equal to 4 plus 4 which is equal to 8. And the next one is f of 1 belongs to which one? See here, 1 less than or equal to, so therefore this interval includes 1, therefore we should use this. That is, instead of x we should substitute 1 minus 1 which is equal to 0. The next one is f of minus 2. F of minus 2. So minus 2 is in this interval, that is x square minus 2. Instead of x we should use minus 2. Minus 2 the whole square is 4. Minus of minus 2 is plus 2 which is equal to 6. And again the next element is f of 7. F of 7. Okay, see where is 7? This interval is less than 7. This interval does not include 7. Therefore, here, say otherwise means the value is 0. Then f of 0. Where does 0 belongs? So 0 belongs in this interval, right? Minus 2 to 1. Therefore, x square minus x. 0 minus 0 is 0. Okay, these are the values. Similarly, they are given for third sum. minus 3, 5, 2, minus 1 and 0. They have given 4 intervals, okay, f of x. So third sum is the assignment for you, okay. You have to find the values of that 5 variables, sorry, 5 values they have given. And then fourth sum. So third sum is the assignment for you. Now the fourth sum, state whether the following relations are functions or not. If it is a function, check for one-to-oneness and on-to-ness. If it is not function, state why. They have given 2 subdivisions, they have given 2 relations, okay. For that relation, we have to check whether the relation is a function. If it is a function, we have to say whether it is one-to-one and on-to. Okay, if it is not a function, we have to state the reason why it is not function, okay. Fourth one, first subdivision is A is equal to A comma B comma C and F is equal to A comma C, B comma C, C comma B, where F is a function from A to A. Okay, F is a function from A to A. What are the values of A? A is A, B, C. It is very easy if you compute this domain and codomain diagram. Okay, then you can check whether it is a function, whether it is one-to-one or on-to. Okay, see here, A is marked to C, B is marked to C, C is marked to B, C is marked to B. Okay, see, is this a function? See, all the elements in domain is marked to some value. All the 3 elements is marked. Therefore, this is a function. Is this one-to-one? No, this is not one-to-one. One-to-one means every element should be marked separately to another element. That is for the pre-image. See, for the image, see, this is the A and B are having same image. Therefore, this is not one-to-one. This is not one-to-one. Is this on-to? On-to means every element in codomain should have the pre-image. But here, A is not having any pre-image. Therefore, this is not on-to. Okay, this is not on-to. See, for the second subdivision, what is the second subdivision is x, y, z. The function is f, that is x comma y, x comma z and z comma x. Okay, f is a function from x to x. Now let us mark in the diagram. X is x, y, z. X to x, y, z. See here. So see here, x is marked to y, x is marked to z, z is marked to x. See here, there is an element in domain which is not marked. Therefore, this is not a function at all. Why? There is an element left in the domain which is not having any image in the codomain. Therefore, this given relation is not a function. Okay, you have to state like that. Now, the fifth sum. Fifth sum. Let A is equal to some set of values and B is equal to some set of values. Give a function from A to B for each of the following. So, fifth sum. What is A? A is equal to 1, 2, 3, 4. Okay. What is B? B is equal to A, B, C, D. Okay. So you are going to give a function which is neither one-to-one nor on-to. It should not be one-to-one, it should not be on-to. Now let us map here. Okay. It should be from A to B. 1, 2, 3, 4. A, B, C and D. Okay. See, neither one-to-one means it is a function. So every element in domain should be marked. Neither one-to-one, not one-to-one means it should not be marked separately. Right. See here. See this. So this can be written as 1 comma B, 2 comma B, 3 comma C and 4 comma D. See, this is a function because every elements are mapped. But this is not one-to-one because 1 and 2 are having the same image, and this is not onto because there isn't one element left in codomain which is not mapped with any of the pre-image. Therefore, this is neither one-to-one and nor one-to. Now, the second subdivision. Not one-to-one but onto. But onto. That is 1, 2, 3, 4. A, B, C, D. Is this possible? Not one-to-one means this should be marked with any one. Okay, this should be marked with any one. But see here, this is not one-to-one. Okay, this is not one-to-one, but this is onto. But this is neither a function. This is not a function because there isn't one element left behind which is not having an image. Therefore, this is not even a function. Therefore, this type of function is not possible. This type of function is not possible because there is no function like that. Okay. Now, the next one is one-to-one but not onto. One-to-one but not onto. One-to-one but not onto. Okay. Similarly, now see here. 1, 2, 3, 4. A, B, C, D. One-to-one means it is like that. Is this onto? No. Since we have 4 elements in A and 4 elements in B, there is no possible to get this like this element, like this function. Therefore, this is also not possible. This is also not possible. The fourth one. What's the fourth one? Fourth one is a function which is made on one-to-one and onto. It should be both one-to-one and onto. See here, this is A and this is B. 1, 2, 3, 4. A, B, C, D. This is one-to-one, right? Every element are mapped separately to other element, and every element in the codomain has been mapped. Therefore, this is one-to-one onto. This can be written as 1, B, 2, A, 3, C, and then 4, D. Okay, this is possible. Okay. Now, the sixth sum. Find the domain of Find the domain of 1 divided by 1 minus 2 into sin x. So, we have seen like this sum in the example. So, since the domain it is a domain from R, but from that we are going to neglect R except for which this becomes 1 minus sin x becomes 0, right? If it becomes 0, the whole term becomes not defined. Okay. So, take this 1 minus 2 sin x is equal to 0 means 1 equal to 2 sin x. So, sin x is equal to 1 divided by 2, that is 60 degree. Sin 60 degree becomes 1 by 2. So, for what values of x we get sin x is equal to 1 by 2 is n pi plus minus 1 the whole power n pi divided by 6 for what n belongs to is. Therefore, the domain is R minus n pi plus minus 1 the whole power n pi divided by 6 where n belongs to is. The same thing we have seen in the example. Okay. Now, next sum. Find the largest possible domain. Here too we are going to find the domain. Okay. Find the largest possible domain of the real valued function f of x is equal to root of 4 minus x squared divided by root of x squared minus none. So, this type of sum we have seen in the example, right? For this we have to find separate domain, and this we have to find separate domain, and we have to combine this. See here, for this root of 4 minus x square, what we get? We get the roots as x is equal to minus 2 comma plus 2. So, the minus 2 comma, the intervals are minus 2 comma 2, minus 2 comma 2, sorry, and 2 comma infinity. Okay, shall we take these elements from here? if we take minus 3, what happens? Minus 3 is 4 minus 9. This becomes negative. If we take 1, 1 means 4 minus 1. This is positive. And this becomes, for here if we take 3, 4 minus 9 becomes negative. Therefore, we are neglecting this both. Since I am writing like this, we have to write in words. Since the value from, we are taking one value from this, then the values for this whole interval becomes negative. Therefore, we are neglecting it. Like this, you have to tell for separate intervals. Okay. So, the domain for numerator is minus 2 comma 2. And then moving on to denominator, x square minus 9. For this, the value of x is equal to minus 3 comma 3. Okay. So, the intervals are minus infinity comma minus 3. Minus 3 comma 3. 3 comma infinity. Okay. Take some value here. Let us take minus 4. Minus 4 means 16 minus 9. This is positive. Here let us take 1. 1 means 1 minus 9 is negative. Okay. And here it becomes positive. If we take 4. So, what becomes? We are going to neglect this. So, the domain here is minus infinity comma minus 3 union 3 comma infinity. So, we are going to combine this and this. That is minus 2 comma 2 intersection minus infinity comma minus 3 union 3 comma infinity. Is there any common element? See here, this minus 2 comma 2 comes here, but that is not included in this interval. Therefore, the domain is null set. The domain for the given function f of x is null set, because there is no elements, no intervals here common. Therefore, the domain is null set. Okay. Now, 8th sum. Here they have asked us to find the range of the function 1 divided by 2 into cos x minus 9 minus 1. Okay, what is the range of cos x? Minus 1 less than or equal to 1. Okay, multiplied with 2 throughout, minus 2 less than or equal to 2 into cos x less than or equal to 1. Okay, again subtract 1. Okay, subtract 1. Minus 1 minus 1 minus 1 becomes minus 3 less than or equal to 2 into cos x less than or equal to 0. Okay. On taking reciprocal, what it becomes? 0 less than or equal to 1 divided by 2 into cos x minus 1 less than or equal to minus 1 divided by 3. Okay. From 0 to less than or equal to. Therefore, this is minus infinity to minus 3. So, see here, what it becomes is minus 1 divided by 3 greater than or equal to 2 into cos x minus 1 and again 2 into 1 divided by, okay, 1 divided by 2 into cos x minus 1 greater than or equal to 0. It should be greater than 0 and should be greater than minus 1 divided by 3. Therefore, okay, union 1 comma infinity. So, this is the range of the given function. Okay, this is the range of the given function. Okay, now see here, this is, we are multiplying with minus 2, right? We are multiplying with 2, so this becomes 2 and here it is 1. Okay, now it is greater than or equal to 1. Okay, now 9th sum. Show that the relation, 9th sum, show that the relation xy is equal to minus 2 is a function for suitable domain. Find the domain and the range. So, this relation, this can be written as y is equal to minus 2 comma x. right? The y means what is y? F of x. F of x is equal to minus 2 comma x. Okay, so for which the domain is R, for which except x is equal to 0. Therefore, the domain is from minus infinity comma, okay, minus infinity comma 0 union 0 comma infinity, that is except 0, the domain is R. What will be the range? Range is also R except the term 0. This is the range. Okay. Now the 10th sum. Similar like 10th sum we have seen in the example. Tenth sum. If f and g is a function from R to R, f of x is equal to modulus of x plus x and g of x is equal to modulus of x minus x. We have to compute both f composite g and g composite f. Okay. See, we already know that modulus of x is x. So minus x when x is less than 0 and x when x is greater than 0. Okay. So what f of x becomes? F of x will be equal to, okay, if x is less than 0 means this becomes minus x. Minus x plus x is 0. If x is greater than 0 means this becomes x. X plus x is 2x. Similarly for g of x is less than 0, x is greater than 0. If x is less than 0 means this becomes minus x. Minus x into minus x minus x is minus 2x. If x is greater than 0, this becomes x. X minus x is 0. Okay, now shall we compute f of x, f composite g and g composite f. First, f composite g. When x is less than 0, f composite g of x is equal to f of g of x. F of g of x when x is less than 0 is minus 2x. Minus 2 into x. Take that minus 2 outside, f of x where x is less than 0. F of x when x is less than 0 is 0. Therefore, minus 2 into 0, it becomes 0. Okay, when x is greater than 0, f of g of x is equal to, this can be written as f of g of x. F of g of x when x is greater than 0 is 0. F of 0. So, f of 0 is automatically it becomes 0. Okay, now this is f of g, f composite g. Now we are going to find g composite f of f when x is less than 0. G of f of x. What is f of x when x is less than 0? That is 0. G of 0 is equal to 0. Okay, similarly for x greater than 0, g composite f of x is equal to g of f of x, which is equal to g of f of x when x is greater than 0 is 2x. This can be written as 2 into g of x, taking the constant term outside. Okay, 2 into g of x. G of x when x is greater than 0 is 0. That is 2 into 0 is 0. Therefore, what we get? F of g is equal to 0 and g of f is also equal to 0. Okay, now 11th sum. So, what they have given in the 11th sum? They have given 3 real valued functions f, g and h. Yes, they have given 3 real valued functions defined on R. Then what we have to prove is f plus g of h is equal to f of h plus g composite h. Okay, then they have asked can we say f composite g plus h. First let us prove here. Now let us take f plus g as another function k. Okay, so see this addition of two functions is also a function, right? So let us take this as, so what it becomes, k composite h is equal to, h of x is equal to k of x, so k of h of x, right? So this k can be written as what we took, f plus g of h of x. This can be written as f of h of x plus g of h of x. So how can we take this? F composite h of x plus g composite h of x. Right? Therefore, f plus g composite h is equal to f composite h plus g composite h. Hence proved. Okay. Similarly, we can prove this. Okay. How can we prove this? F composite. Now, let here we take g plus h is equal to k. G composite k of x is equal to, sorry, f composite k of x is equal to f of k of x. So, instead of k, we can substitute g plus h of x. This is equal to f of g of x plus f of h of x. Right? Then f composite g plus f composite h. So they have asked us to justify our answer. This is how we have to justify the answer. This is possible. This is possible. This is how we have to justify the answer. Now the 12th sum, if f is a function from R to R, this is denoted by f of x is equal to 3x minus 5. So this sum we have seen, like this sum we have seen in the example. So 12th is the assignment for you. So with this we are completing this video. Let's see some other sums in the next part. Okay, next video. So 12th sum is the assignment for you. Thank you students. Let's meet in the next class.